Hello, my name is Felipe. I'm a software developer from Argentina. I have been working on development for the last 8 years and specializing on front-end for the last 6. Today I will be showcasing an app I built for a technical challenge I received from a company. The idea of the application is to allow two parties to reach an agreement on a price. The application is built using Next.js, TypeScript, is using Redux for state management, is using Jest for testing, and is using Undesign for the components. So, the application so far only has one screen, it's working as an admin view, and the reason I decided to go with an admin view is that there was a lot of emphasis in the challenge on how the communication would work between party A and party B, and I think that the best way to be able to see this communication was with an admin view. If I were to only be showing party A or party B, I would be missing the other side. Again, this code is totally reusable, and I could decide to just show one screen or the other, and in a real production environment, that would be the case. I would have more pages based probably on a login, and I would decide based on what users are logged in, which screen I'm showing. But again, I think for a demo purpose, it's much easier to see it this way. So, as I said, we are using Redux, so we start with an empty state. We have party A that can make an offer for a product, and we have party B that receives offers. At first, he's not able to agree or disagree because he didn't receive any offers. So if I make an offer of 12, we get a real-time update on party B. So the way that this application is working is that party B receives all the updates in real time, but party A doesn't. The reason that this happens is not because of a technical limitation, because it's really easy with the code that I already have to make them both be synchronous and get the information in the instant. But the application was really, the challenge was really clear in the fact that we need to wait for a refresh of party A to actually show him the latest info, right? So what can the user of party A do? If the user of party B didn't click on agree or disagree, we are still waiting for the response. So he's able to change the offer, right? So he can do a bigger offer. This will probably happen if we are not getting a response, so you try to make a bigger offer to get the attention of party B. And then party B, let's say that disagrees because he doesn't agree with this offer. So what happens if this user tries to offer more? Then we get a message that lets us know that there was an update from party B since your last refresh, and you're able to make a refresh. And now we get the info of what happened, right? So it tells you party B did not agree to the offer of 24. And now that we know that he didn't agree, we can make a new offer for 32. Now, again, we can see that party B always receives the updates on real time, and this time the user is going to agree because the price seems like a fair value. The moment he agrees, the options of the buttons disappear because there isn't anything more that the user of party B can do. And if the user of party A tries to offer a new value, he will get the message, and if he clicks on refresh, again he gets the notification that the user of party B agreed on the price. And this will be a settlement, right? We have both parties are agreeing on the price, and the settlement is done. If we click on refresh, we go back to state 0. The reason of this is that we are using Redux. I decided to use Redux because this was a front-end challenge. If this was a real case scenario, we would probably have built something with an API, with a database, and we would receive all this info from those places and not Redux. So we would have persistence of the data. And of course, we will also use something like WebSockets to get real-time information on both screens. Again, and decide when we actually want to do the refresh, because we need to remember that this is a limitation of the challenge. The challenge was really specific on the fact that we shouldn't override the UI of party A. We need to actually wait for the user to agree with the refresh. And yeah, that is basically it. So something else I can show is that this is responsive. This is working fine on different screen sizes. So we have no issues with this. I can also show that this is deployed on a public repo. I'm going to share this repo, and this video is going to eventually be embedded on this README, so it can be checked. Here I added some considerations as to why I decided to do some things this way. Here are some explanations of how to run the application locally. That is really easy to do. We have the deployed URL that can be checked. This deployed URL is using Vercel. So again, if this was a real case scenario, we could have taken advantage of Vercel and linked to the analytics, the logs, and all the things that Vercel gives us. We have tests. Here we can see that we have the tests running and they are working fine. So our components have tests and quite a high coverage. And then I have here some future improvements that I would do in the case that I will have more time, because it's important that the time frame of this challenge was only 4 hours. And yeah, that is basically it. I'm going to make one more small video to showcase the different technologies I use and how the application is built in terms of code.